Alkanes, halogens such as fluorine, chlorine, bromine or iodine, nitro groups as well as ethers have an equivalent priority when it comes to the functional group, and that's the lowest possible priority. And that's all we've seen so far. But it is possible to have higher priority functional groups in your molecule. And when this happens, you must take extra care when it comes to naming. This is an excellent example of such a problem, but we start in exactly the same place, by determining the parent system. This molecule has 6 contiguous carbons, so we call that hex. They're in a ring, so that's going to be called cyclo, to give us a parent name of cyclohexane. The next phase in naming is to give the locations of the functional groups attached to the parent system. And this is where we need to take extra care. The highest priority functional group must be given the lowest possible number. And in a ring, that's always going to be 1. But what's the highest priority functional group here? We've got a choice between methyl as an alkane, an alcohol, and a ketone. And the winner is, it's a ketone. So ketone is going to be at position 1. From there, we've got a choice. Do we number in a clockwise direction to give our functional groups positions 1, 6, and 5? Or alternatively, do we number in an anti-clockwise direction to give our functional groups positions 1, 2, and 3? To answer that question, we look to the lowest number, but in both cases that's 1. So here we need to look to the next lowest number to see if there's a difference there. Here we're looking at choice between 2 and 5. 2 is lower than 5, so 2, as it were, wins. We're going to number in an anti-clockwise direction to give our functional groups positions 1, 2, and 3. Okay, that's the location sorted out. Next, we move on to naming the functional groups. And again, extra care is needed. Very often, the functional group has 2 possible names. One, if it's the highest possible functional group in a specific molecule, or in another case, where it's a lower functional group in a specific molecule. We've already established that the ketone is the highest priority functional group in this case. So we're going to call that one, and one appears after the parent name as a suffix. If, in another example, the ketone were a lower priority functional group, it would be called oxo, and that would appear before the parent name. That's not the case here. What else do we have? Well, we've got an alcohol. The alcohol in this case is a lower priority group. So we call it hydroxy, and this appears before the parent name as a prefix. If in another example, the alcohol were the highest priority functional group, it would be placed after the parent name and be called ol. That's not the case here again. And finally, we have a methyl group. That's the lowest priority as an alkane. We need to place these names in alphabetical order. So what we're looking at is 2-hydroxy, 3-methyl, 1-one. The one, we don't have to worry about the alphabetical order because it's always going to be a suffix. It's the set of prefix names that really need to be placed in alphabetical order. So the correct name here is going to be 2-hydroxy, 3-methyl, 1-cyclohexane. But when the highest priority functional group is given position number 1, we don't have to write 1 in the name. And if you don't see a number given to the highest priority functional group, you can assume that number's 1. So the absolute name here is 2-hydroxy, 3-methyl, cyclohexane. Notice there we dropped the 1. Okay, so beyond alkanes and alkane equivalents, we need to give the highest priority functional group the lowest possible number. And that's the takeaway message from this example.